In this lesson, we're going to be using Descartes' rule of signs to determine the potential number of both positive and negative rational solutions to a given polynomial. So Descartes' rule of signs, part one, dealing with the positive roots of a polynomial, we're going to reference a function f of x. The number of possible solutions is equal to the number of sign changes in the coefficients or less than that number of sign changes by a multiple of 2. The easiest way to really wrap your brain around this is really just to go through an example. So I have a really ridiculously long polynomial function, but the longer the polynomial, the more complex it is. Actually, the easier it is to actually grasp Descartes' rule of signs. So if we look at this and we look at the coefficients in front of the variables, namely the numbers that are in front of the x's. So we have a -8, the +2, another -8. This is a +1, +14, -3, and then a +11. What we are going to be looking for is how many times is there a sign change? Does the term go from positive to negative or negative to positive for the function f of x? So first, let me just highlight all of the negatives. So the first term is negative, the third term is negative, and then this term is negative, and then all the positives are, well, obviously the ones that are remaining. There's a positive here, a positive here, positive here, and positive here. So what we're noticing is we're trying to figure out how many sign changes there are. So the first term, we went from a negative to a positive. That's one sign change. Then to go from the second term to the third term, we go from positive to negative. That's a second sign change. And then we're going from negative to positive. There's a third sign change. But next term is a positive, so we're not making a change at all. We're still stuck at 3. But then we're going to make another change from positive to negative. So now we're at 4 changes. And then we're going to do another change from negative to positive, giving us a grand total of 5 sign changes for the function f of x. Now we're going to hold on to that number just for now. We're going to deal with it a little bit later. But next we're going to get to part 2 of Descartes' rule of signs. In part 2 of Descartes' rule of signs, we're going to be finding how many negative rational roots there are, but we're not going to deal with the function f of x. Instead, we're going to deal with the function f of negative x. So what we're going to have to do is we're going to have to find f of negative x. So we're going to rewrite the equation, but everywhere I see an x, I'm going to put a negative x instead. So it's negative x to the fifth minus 8 times the quantity negative x to the fourth plus negative x to the third plus 14 times negative x to the second. And as we kind of were dealing with in the last lesson, dealing with end behavior, we found that, in reality, if the power of a negative is even, then you're going to have an even number of negative numbers, and those negatives just go away. They don't do anything. So the first part, the -8 times negative x to the 6, the negative x to the 6 is just going to be x to the 6. So that'll just turn into negative 8x to the 6. So this negative kind of just goes away. But then the second term, if I have a negative x brought to the 5th power, well, I've got 5 of those negatives. And if you have 5 negatives, that is going to be a negative when you multiply it all out. So it's -2 once we multiply it by the positive, x to the 5th. Then we have a negative x to the 4th. The negative is going to go away because of the 4th power. And then we have a negative x to the 3rd. That negative is going to stick around. Positive and a negative make a negative. Then I have a negative x to the 2nd. Negative is going to be squared and it's going to turn positive. So plus 14x squared. And then a -3 and a negative x make a positive 3x and then plus 11. So now we have found what f of negative x is. And we're going to go through the same procedure we did in part 1 of Descartes' rule of signs. We're going to count the sign changes. So I'm going to highlight all the negative coefficients. So the first one, the second one, third term, the fourth term, the fifth is positive, the sixth is positive, and the seventh is positive. So positive, positive, and positive. So to go from first term to second term, no sign change. It went from negative to negative. Second term to third term, no change. It went from negative to negative. Third term to fourth term, still no change. It went from negative to negative. But then when we go to the fourth term to the fifth term, here's our first sign change. And then the rest of the problem, there are no sign changes. So for f of negative x, there's only one sign change. All right, so now it's time to bring all this stuff together. So for f of x, we had a total of 5 sign changes. For f of negative x, we had one sign change. So let's determine the number of positive and negative solutions. So the first box for f of x, this is what is going to determine the number of positive x-intercepts for this function. So for the positive, the number of positive real solutions, it's either going to be, well, we had 5 sign changes. It's either going to be 5 solutions, or we're going to count down by 2s. Or it's going to be 3 solutions, or it's going to be 1 solution. And I can't subtract you from that because I can't have negative number of solutions. And then the number of negative real solutions is just going to be 1. So because of that, I know that if I were to find where this function crosses the x-axis, there could be 5 positive answers, 5 positive roots. There could be 3 of them. There could be 1. I don't know. It's one of these. But for the negative solutions, there's only going to be 1. So let's go through that process just one more time for a new function. So here I have the example 2x to the fifth plus 7x to the fourth minus 5x cubed minus 8x squared plus x plus 1. So let's do the first part where we're going to find the sign changes. So all the negatives are here, and all the positives. The first term is positive, even though we don't write it as positive. Here are all my positives. So let's count the sign change. Positive, positive, no change. Positive to negative, there's my first change. Negative to negative is no change. Negative to positive is my second. Positive to positive, no change. So let's now find f of negative x. So that's going to be 2 times negative x to the fifth plus 7 times negative x to the fourth minus 5 times negative x to the third minus 8 times negative x squared plus negative x plus 1. All of the odd powers, the negative sticks around. So for the first term, this will become a negative 2x to the fifth. The second term has a negative x to the fourth, so that negative is just going to go away. It's going to retain the positivity, positive 7x to the fourth. Third term is an odd power. The negative is going to stick around, but it's next to a negative 5, so it'll become a positive 5x to the third. Then the fourth term, I have a negative x squared, so the negative is going to go away. So keep the negative in front of the 8. Then plus a negative x is negative x, and then plus 1. All right, so we're going to highlight all of the positives, all the positive coefficients. And then I'm going to highlight all the negative coefficients just to make it a little visually more appealing and easy. First, we're going to go from negative to positive. There's one change. Positive, positive, no change. Positive to negative, second change. Negative to negative, there's no change. Negative to positive, there's my third change. So, the number of positive real solutions is 2, because we got 2 sign changes. If I subtract 2 from that, I'll get 0. So when I graph this original function, there's either going to be 2 positive solutions or 0 positive solutions. the number of negative real solutions is either going to be 3, because that's how many sign changes we got for f of negative x. If I subtract 2 from that, it's 1. And I can't subtract 2 from that without going negative, and I can't have a negative number of solutions. So this is my answer.